Okay, this is where we left off last time. Again, if it's a element, it wouldn't be able to be broken down chemically or physically. A compound could be broken down chemically. So, symbols and formulas. Chemists are by their nature lazy, and every discipline has its shorthand, and we use shorthand a lot. And so there's most of the things that I'm going to care about with naming will be about symbols, formulas, and names. So, just so you know. What do chemists use to represent elements and compounds? Well, we use chemical symbols to represent elements and chemical formulas to represent compounds. So H2O would be a chemical formula, and that represents the compound water. Na, capital N, lowercase a, is sodium, and we use that to represent the element sodium. So, back in the day of the alchemists, they had all sorts of different symbols, and chemists decided that we needed a more systematic approach. In fact, it was John Dalton, and he used both the symbols, the drawings, and the chemical names to represent things, and we needed to have something a little bit more systematic. So, the symbol used today for the elements were based on a system developed by Swedish chemist Jans Jacob Berzelius, and you don't need to know his name or his dates, his year of birth and death. All you need to know is that he based those symbols on Latin names of the elements. And so this 1848, we didn't have all the elements yet. We hadn't discovered them all. So not all names come from Latin. Some come from other sources. So each element is represented by one or two-letter chemical symbol. And I will be insistent on this. First letters of the chemical symbols are capitalized, and the second letter, if used, is always lowercase. So it has to be a capital N and a lowercase a. The English name and the Latin name of an element are similar, then the symbol may be having the same first letter or two letters. For example, calcium is Ca and nitrogen is N, sulfur is S. However, not all of them are as easy. So, sodium, the Latin name is not very similar, and so it does not start with an S, it starts with Na. Potassium is a K, antimony is Sb, copper is Cu, gold is Au, silver is Ag, and these I am going to insist that you know all of this table, so please make sure that you write these down and start practicing them. They will appear on your next test and every test after that. So Pb is lead, Sn is tin, and it comes from, as I said, it comes from the Latin, not from the English. Chemical symbols are shorthand. They make it quicker to write formulas. You wouldn't have to write out for, let's say, sucrose, 22 hydrogens, 11 oxygens, 12 carbons. You would be able to write just C12H22O11. So, makes it much shorter. The subscripts in the formulas tell you how many of each atom type there are, and it is the subscript after the letter. So the 2 indicates we have 2 hydrogens. If there is no subscript, then it's one of the other, and so there's 2 hydrogens to 1 oxygen. And it is always, if it's that chemical or that compound, then it's always in that combination. And you'll understand later what order you put them in and why. Chemical symbols are abbreviations for the names of elements in what language? And you should know at this point that that would be Latin. Periodic table, a preview. Periodic table is probably the most useful thing we have in chemistry. And if you understand it, you can do so many things with it. So why is it useful? Well, it's an arrangement of elements in an order which separates them into groups based on their repeating properties, which is really interesting. Everything in the same column has similar properties. The periodic table allows you to easily compare the properties of one element or group of elements to another. And when chemists are trying to develop new compounds, they use the periodic table and say, well, I know what potassium does in this case. What does sodium do, or what does something else? So maybe they want to see if calcium will be the same properties as potassium in a compound. So it's kind of an interesting way or a different approach to varying the properties of a compound. So here we have them arranged, and you'll notice the number on top is the order in which they're placed in rows across on the periodic table. We skip the middle blocks sometimes until we get down to the 4th row, but then we just keep going. So each element is identified by the symbol in a square. The elements are listed in order from left to right and top to bottom by atomic number, and that is a unique number for each element. It actually tells us the number of protons in the element. And the atomic number of the element is centered above the symbol, and it is a whole number. It is not a decimal. The decimal would be its atomic mass, average atomic mass. So hydrogen is the lightest element. It is in the upper left corner. Helium is in the upper right corner, and it is atomic number 2. Then we come back to lithium, and it's in the very left column in the 2nd row. And it continues on. Each row of the periodic table is called a period. You do need to know that. It is one of your vocab words. And there are 7 periods on the periodic table. The number of elements per period ranges from 2 for the first period up to 32 in period 6. You'll notice there are some elements listed below the periodic table, and that's because they are should be inserted, but it would make the periodic table very, very wide. Within a period, the properties of the elements vary as you move across the period. This pattern of properties then repeats as you move to the next period. So lithium and sodium and potassium all repeat the same type of properties. So each family or group is a vertical column, and we have them lettered over the top with things like 2A, and the A or B indicates whether it's a main group element or if it's a transition element. And 2A represents the elements in the 2nd column: beryllium, magnesium, calcium, strontium, barium, and radium. Which elements are included in the periodic table? That should be an easy one. All known elements are included. We don't disallow any elements. We do not put any compounds in, but we put every element onto the periodic table. Oh, we're almost done. So, the key concepts. Compounds can be broken into simpler substances by chemical means, but elements cannot. If the composition of a material is fixed, the material is a substance. If it can vary, then the material is a mixture. Think milk, whole milk, skim milk, 2%, heavy cream, etc. Chemists use chemical symbols to represent the elements and chemical formulas to represent compounds. Periodic table allows you to easily compare the properties of one element or group of elements to another. So your vocab words: element, compound, chemical change, chemical symbol, periodic table, period, group. The main idea is that matter can be made of elements or compounds. Elements and compounds are pure substances, but can be physically combined to make heterogeneous or homogeneous mixtures. These physical forms of matter may undergo physical or chemical changes. The end. So I'll see you guys in class. Thanks for listening.